Yeah, okay.
There we go.
I was gonna say, I think I see at the top that it's recording, so. I can use my mouse to point at things too, so that people online can see it.
Yes, you'll see a couple of words then. So this is the second Departmental Safety Day, and so we had Evan England last time talk about it was we'd like to know more about the chemical waste as well. So we invited Jodi Ogilvie to talk about that today. Just to let you know, and also we have some questions to get feedback on the event as well. So that will help us in the future with the next events that we do. Evan, do you want to say a couple of words?
Yeah, so I'm just Evan Ingman. I was here last time doing the first thing about chematics. Really all I want to say is that we're the College of Food and Science, I was getting confused with College of Food and Agriculture, CFAN.
Yeah.
So I plan on doing food science, a list of audit items that we look for, and I can send that out to the college as well. Just some items that we cover when we go through the labs. So if you want to get a head start on what we're looking for fluid, then you have more time to give us questions while we're actually on site. So with that, I'll just leave it to Jodi.
Yeah. So I am Jodi Ogilvie. I'm the Lab and Research Safety Manager. So I manage the research safety program. And we, our program we not only maintain the compliance, but we do consultations and things like that. So my staff are people like Evan, and then I even have service partners myself. I'm the service partner for the College of Pharmacy. Beyond that role, I'm the chemical hygiene officer. So what that means is that I manage chemical safety, and I am involved whenever there's hazard assessments, especially when there are like high hazard chemicals, things like that. So that's why I'm here kind of doing chemical safety training. And what was communicated to disposal, I'm gonna turn my video off, so hi. Not only about disposal, but about roles and responsibilities, things that people are responsible for, chemical management, and so nothing super in depth, and then chemical disposal. And the most important thing is really the Q&A. So before the presentation, there were, okay, nope, I just wanted to make sure. Mostly, I just want to make sure that I answer any questions that you have. So this talk is really fluid. It doesn't have to be very regimented. I have slides to talk about, but if out of it what you want. And so if there will be monitoring the chat, if there are any questions within the chat, that'll come up. And then beyond that, I have incorporated the questions that you pre-submitted for the presentation. So there too. So first, starting off with roles and responsibilities, a question came through: who's in charge of making sure that labs are compliant with understanding the rules and enforcing chemical usage? And so for that, I'm responsible. So you are the employer of the graduate students or the students that work in your space. And so you are ultimately responsible for kind of knowing the regulations around your areas and then making sure that the staff in your area, the reason that the PI is responsible, the PI or supervisor, because not all supervisors are PIs, I guess. The reason is because you are the one that's the most familiar with your area, right? So you know what hazards you have, and so with the partnership with University Health and Safety, you can talk to us and we can say, okay, here are the requirements for the work that you want to do. And then we can help you jump through those regulatory hoops. Really a lot of safe, but in some cases there are more forms to fill out or a formalized process. Like if you work with biological materials, we can help you with that or things like that. And then another question was, what's the biggest? That's employee injury. So, there are, in some cases, there could be regulatory fines. A lot of times the lab themselves don't pay them. In a lot of cases, and that's why we kind of send out the email blast saying that, hey, the county is coming around to do a waste inspection. But for me, the biggest consequence is that someone in your lab could get hurt. And it doesn't necessarily mean that it's property damage. It could just it could lead to a minor injury or a chronic injury or something like that. And so that to me is the biggest consequence of noncompliance of the rules is employee injury. Then beyond that, who else is here to help you? So sorry, I wanted to get that right. So we provide training on requirements. We do that via in-person training, and we do that via our online training. Our online training, we recognize that our online modules are out of date. We update them as we're hoping to make those a little bit more interactive for staff. But really, the online modules you kind of do initially, and then in some cases annually, depending on the hazard. And then beyond that, the training verify compliance through our lab inspection program. And so we are bound, by the university to make sure that the labs on campus are compliant. And we had in 2020, we had an internal audit, and they audited our lab inspection, a more defined kind of tier of inspection timelines. So in your group, I believe, Evan, correct me if I'm wrong, most of you are every other year. So in some cases, our higher hazard labs, those might be every year, and it kind of depends on the hazard. And so we're responsible for managing that process. We also aid labs in hazard assessments. So we come through and do consultations anytime you have something new or a new piece of it, or at least get you to the right expert within our group. And then beyond that, we help with investigating incidents and near misses. And near misses to me are really important because that allows us to get a kind of like a lagging indicator. It's already happened. So how do we correct it after the fact? With a near miss, it's like, oh, this could be worse next time. So let's fix it now. The department safety officers. Yes, there you go. I'm sorry. So your department safety officer provides location-specific guidance, so guidance specific to the building, to the hazards that you have. They notify UHS, and they also help us with inspections. So oftentimes the department safety officers go along with us. During the pandemic, we've had situations where some of them will go along because we want to reduce the amount of people in the lab, but we're kind of ramping back up to that normal process. And they know where the labs are. They work within your department, right? So you work with them, and so you know them, and they're an easy person to ask questions to. So those are kind of like the roles and responsibilities of the key safety players within your department. Is all going to be focused on chemicals. So cradle to grave chemical management, right? So this part is the beginning, knowing how much you can have. And this is really technical, and the image is why chemical inventories are important. So per the building code in Minnesota, the University of Minnesota has its own kind of building code standard that we follow. You are only allowed to have a certain amount of chemicals per control area. In most locations, it's like per floor. That's why the chemical inventory system comes into play, because when you enter a chemical in, all of that data is behind that chemical in our database. And so we can run a report and say, oh, this floor has, a certain amount of flammables on it, right? And then we can look at that. So that's Minnesota is unique that we have our own building code office. Normally it's like the state fire marshal that would come in and do inspections. They normally don't do inspections of areas unless there's like a construction project. But we are usually the ones that work with labs to help them understand, right? So I wouldn't expect you to necessarily know offhand, like I can only have this amount in my lab. It's us, everyone has, and we can help if there are problems in areas. Yeah.
How do you know how much you have?
How do we know how much you have? So when you put your inventory into the Excel spreadsheet, and it tells us, because all of your chemicals are coded by hazard class. So that's a good question. If your inventory isn't in Chematics, we don't know, right? So for your spreadsheet, and we would put that into Chematics or help you put it into Chematics. And then because the Chematics waste and inventory are in the same module, and they have a database, full hazard profile, right? So GHS hazards, fire code, and then building code. And so that our system does like an automatic calculation. So that's, yeah.
Are you gonna talk more about that?
Yeah.
I'm gonna hold on to you.
Okay, sure. So for that, the quantity that you can have is really affected by where you are in the building and the attributes of the building. So that this line right here is ground level, the dotted line right here. And then as you go up, you can have less. And as you go down, you can have less. And so we start at the first floor above grade, and then you will type, and this is really just for your information, mostly an overview as to why there are limits on certain things. So if a solvent is flammable, there are certain flammable, if that makes sense. The other thing it's affected by, so it's affected by the floor that you're on. It's affected by the construction material of the floor that you're on. So in a lot of cases, we say like this is built such that they have a 2-hour burn time, right? Another piece is the presence of sprinklers. If your building has sprinklers, you can have twice as much as a building that doesn't. Around and do inspections, we're really looking to see are flammables in appropriate cabinets, things like that, because if they are, it actually doubles the amount that you, basically all this does is it produces barriers so that if there is a fire, if there is an incident, you can have more if there are more barriers to stop that fire or incident from spreading, right? And it also denotes control areas. So you can have certain control areas, so like that are walled off by those firewalls, they can have larger quantities inside of them. This is all stuff that University Health and Safety, when we're doing construction projects and things like that, that's where it comes up the most, is can we put this new lab in here? They have this many chemicals, or they have this, and or we might want them on the ground floor kind of thing, if that makes sense. So that's storage limits. That gets into the chemical inventory. So I believe, what year was it? It must have been 2019. They came through and did a presentation on chemical inventory, or was that a different group? Okay, I've been rolling out the chemical inventory system. The system is, again, an add-on to our waste disposal system. And what it does is it feeds off that database to help us run hazard reports for the buildings. Inventory are the ones that have the GHS symbols that you see here. So if it's a health hazard, if it's a flammable, corrosive, explosive, oxidizers, things like that, what's required to be in the inventory, and then the exemptions. And the reason why is because those have limits within the Minnesota State Building Code, right? So you can only, yeah, go ahead.
Oh, so it only counts if they have these symbols, not as a symbol.
It is, so if with the updated GHS, if it has this symbol, it's of a reactive like level that it was just the question of like whether if it has this symbol, then it needs to go in the inventory. And the answer is yes. In some of the older bottles, they might not have that. So in general, it's best to try to put required to track in the inventory certain things. Now, I will say that you can track them. This isn't like a don't put this in there. This is a put whatever you want in there, but these things are not required to go in there. So things like non-hazardous solutions, so buffers, media, consumer products, so like your cleaning products and stuff like that don't generally go into kinematics. The caveat to that is pesticides, which I don't think you have to worry about here. Dilute solutions, so if it's less than 1% of a hazardous component, so if it's to go in there. If it's a secondary bottle, like a squirt bottle, it doesn't need to be inventoried separately. If it came from another bottle in your lab, the only exception to that is it's still flammable at 70 proof. So that's the only time that you would take something from a first bottle and dilute it, and you actually make more of a hazardous, chemical. And then the other thing is hazardous waste. And the reason we don't have something that's already in your lab, and that also it's not stored there permanently, right? So it's something that's, so that I think is my last, do you want to wait until the end?
Yeah, I guess I wasn't in my lab technician retired recently.
Sure.
I wasn't really aware that we were required to put it in. Is it going to be updated? We're going to update the other software, safety software.
That's a really good question. So the question was, is Kinematics going to hang around or is it going to be updated? For the time being, chemical inventory is going to stay that module. So the modules that we're updating are the inspection module, and then the radiation module is going to be the same thing. So, and I don't know if I'm allowed to say the name, but we're going to one software for both of those modules. They do have an inventory module and a waste module. The problem is that our waste process rules can't handle it. And so what we'll do is we'll see how the relationship goes with chemical, with lab inspections and radiation. And then we'll help them develop out their waste module so that we can all go into the same thing. I don't know if any of you have noticed, but the waste module has been really weird recently. There've been a lot of glitches, and it's just not as supported as it once was. I think they're in the sunset of the career. So like what we have right now, for the most part, works. Definitely for inventory too, because a lot of the inventory modules we looked at didn't have those building code reports, and we need that. So
would it just be migrated eventually?
yes. Yep. But the good thing though is that if your chemicals are in the Kinematics inventory system, we can add it into any other inventory system. Yeah. So the work of getting it into Kinematics is not going to be wasted. Yeah. Yep. Chemical labeling. So in terms of sort of label that communicates the hazard and then the identity of the chemical. Manufacturer labels, that's kind of up to the manufacturer. So however they come labeled, it's not up to you to redo that label unless for some reason it falls off. You're aware, but you can either label each container with the identity of the chemical and the hazard, or you could label the container location. So in my research lab, way back when I was an actual chemist, I would take all of my squirt said flammable solutions, right? So they said the name of the chemical on it, but they didn't necessarily have the hazard. And by the end of my shift, I put them back in an area. And I'll show you an example of that too. Or have out and you can color code them and it has the acronym and then what the hazard is. Yeah.
Do you know where we can get the GHS?
Yes. So the question was where we can get the GHS stickers. We have templates. Mostly that's just if you printed it off and then stuck it on with tape. I found that packing tape was pretty good. It was pretty resistant to solvent. If you took and that's a cheap bundles, cut it out, apply it with packing tape. Otherwise, I think that people have gotten them from Umarket. There might be some on Umarket. And I'll show you another example. It doesn't have to have the GHS symbol. Another example are these ones over there. One. So you can do NFPA, meaning that the blue is health, the red is fire, the yellow is oxidizer, and then the white is like a special hazard. So you can do the GHS. Yeah, go ahead.
But can you also, instead of having the symbol, write the hazard?
Absolutely. Yeah. Yep. Sorry. Yes. You can also write the hazard too. Yep. The name and the hazard on it. So you can write, there are some examples that I have that say flammable, So here's an example of an area where they have a lot of non-hazardous salt solutions and buffers. Instead of labeling every bottle and putting a whole bunch of acronyms on their list. So this is the labeling requirements come into play when the bottle is around for more than like a day. So more than a shift, right? So at the end of the day, if you put it back where it belongs, you're good. The other piece is the symbols, and they have colored stickered dots. And then they have their list of chemicals with the colored stickered dots. And then their bottles actually have the colored sticker dots on them. So this lab kind of went above and beyond, but they really wanted to do that. So those are just some examples. Easy ones. So we had a situation, I think it was 2015 at this point, where OSHA came to investigate a complaint. It was actually on the St. Paul campus. And when they got there, they cited us TOH on it instead of ethanol and flammable. So we were fined for the container violation. And this is system-wide too. So if someone went to the Morris or Crookston campus and they found a violation, right? So that's why we kind of, when we do inspections, we check for labeling and stuff like that. Yeah.
So those bottles having ethanol 70%, the students use to clean them. We get citation if it's okay.
Yeah. If OSHA were to come in, which is few and far between. Did you have anything to add with that? Or is what I'm saying accurate? Okay. Yeah.
The students use the bottle.
Yep. So, so they just delete the parent bottle?
Yeah, then when it's finished.
Yep.
It could be recycled for
Sure.
time as water.
Perfect.
Especially those spray need to have specific just for ethanol 70%.
Well, you could just say ethanol and then flammable. You know, it doesn't necessarily, if it's 70%, or I think you have to go down really far to make it so that ethanol is not flammable. We'll just write on it with Sharpie, as long as it's touched up. The only issue that I've always had with writing on it with Sharpie is if it dribbles a little bit and then it makes the ink run. So
And just that doesn't need to be labeled.
bleach, you would just label it as like corrosive. The only one that doesn't require a label at all is water, because it's universal. So the other thing that I will say is that there does need to be communication that it's not a FIC rule, because we've had unknowns in areas, and we've had facilities people come through and there's like a spill and we end up having like a full hazmat response because they didn't know it was, you know.
So there's a, bottle buffer should say not hazardous.
Or it could be stored like that. Or you could put the name of the buffer, like a lot of people, in my areas, I see LB and it'll just say non-hazardous. And so, yeah.
We store buffers in the refrigerator.
Yep, that's fine. So you can label the front of the refrigerator that says all solutions are not hazardous.
You can just do it on.
Thing is pretty flexible. In my lab, we used to store our research samples in there. That gets a little bit more complicated. So with research samples, if you don't know the toxicity, oftentimes I'll say like consider toxic or something, but then there's that communication there. That chemical management and proper storage, this is pretty second nature, but I'll go through it really quick. First, segregate chemicals by hazard class. And so that's why I have these little boxed up. Most flammables should be stored there unless it's in a squirt bottle, or working solvents. Working amounts of solvents don't need to be in a flammables cabinet. The reason why is because the quantities that you're allowed to have get lower, if they're out. Corrosives must be segregated within a corrosives cabinet. So in some cases, you'll see it, especially if concentrated corrosives are stored in a non-corrosives cabinet, it'll start eating away at it, right? Corrosives, talk to us, or we can talk to FM, because they can coat that with something that'll help prevent that from happening. We've seen a lot of cabinets that are pre-installed with hoods that just still have metal components in them, that we're sure that you're segregating incompatible acids. So the most common example I see is where someone will have glacial acetic acid, which is technically flammable, next to like an oxidizing acid that could theoretically react together. So like one bottle of nitric acid or perchloric acid, and like put it in its own little secondary containment bin to show that it's not compatible. The other thing is that it's best practice if you segregate, you don't have the space to do that. And so if you do have them in the same cabinet, make sure they're in different trays, and then make sure that you kind of watch for any reactions, right? Usually you'll start to see salt form around the opening of a bottle. But really what we're looking for in terms of segregation is kind of that acknowledgement that it's incompatible, right? So that the separations can be through space. Most times it's, and then gas cylinders must be upright and secured. And then if they're not in use, like if they don't have a regulator on them, just keep the safety cap on them. And then the bottles, so like the lecture bottles and things like that, still make sure that they're stored in a way that's controlled so they're not going to roll around. But oftentimes they can't be secured to like a wall-mounted system. Any questions with storage? Okay. One of the questions that came through was about potentially explosive chemicals, or chemicals that can become reactive over time. The example that was given out, it can become explosive. So you get crystals, a lot of times it'll detonate if you open the cap or something like that. The biggest one that we see around campus, and you may recognize this hallway, is a peroxide forming chemical. So in this particular, which is a class A peroxide forming solvent, what that means is that it forms peroxide just sitting there, right? So a lot of times you have to do something to the chemical in order for it to react with air to form peroxides, like concentrate it, like evaporate it, or something like that. But with class A is just, air seepage through the seal. This bottle expired in 1984, which was the year that I was born. And so that's why we had the bomb squad come and pick it up, because we didn't want to touch you. So this is actually the St. Paul Bomb Squad. We have a pretty good relationship with our Minneapolis and St. Paul Bomb Squad, and they actually use this as a training exercise. So what they'll do, they don't want it to happen often, right? So they use it as a training exercise. So what I did was I actually ran a report of before I came here, of the chemical inventory that we have for this building. And I found that the most common examples, those ones. So isopropyl ether, I don't know that anyone had them in their lab right now, because it would have rang some bells for me, but that's one that we found in here in the past. 2-butanone isoamyl alcohol is one that we see a lot in bond, right? Like a bond that's susceptible to oxidation, right? So that's kind of, we have the list that I have linked down here below. You can look at that list and it'll show you the chemical structures too. So you get an idea of like the motifs that oxidation, right? Like the structural motifs. Yeah.
So to say, because some of the labs have got old chemicals.
Yeah.
And we might not necessarily go away from here, we go and check out some of the chemical stocks and we find some of these chemicals
Yep.
in the chemical process, whatever it might be. What would be the procedure that we should do? If we find, say,
What procedure would you go through if you left this talk today and found some of these chemicals in your lab? There's a couple of things that you can do. So a lot of the peroxide forming chemicals now will have an inhibitor in them. So those ones, there's some sort of like diethyl ether that will inhibit that peroxide formation. So if it has that in there, it's usually not a big risk. Another indicator is if you see that it's old, you can get rid of it through the chemical waste program. So if it's something that you don't use and you don't want to deal with, just to dispose of it through chematics. And in the comments say, I have not tested this for peroxide. Something that's not old and you might want to use it. On our website, we do have like a guidance document that has the strip that shows you kind of how to test for peroxide. And some of them you dip them in water first and then you'll dip them in your solvent and it'll turn a color. And that color will indicate to you whether or not there are peroxides present. I will say that like after the second reason why this is important is because it not only protects your staff, but it protects our staff. So this is an explosion that happened in 2019 in our wake, had a lot of old chemicals. They didn't recognize that one of the bottles was a peroxide forming chemical, and their processes, just off the picture here, they're like big funnel out by a tanker truck to be burned for fuel, right? But in this case, when the technician went and threw the empty bottle into the cart, it detonated. When I say detonated, it means it shredded that cart. So it like blew insulation off walls in other rooms. Like it was a huge shockwave, right? So not only disposing of your old chemicals is good for you, but it's good for our staff too. So our hazardous materials technicians often test them now before they bulk them. So those dip strips. And then at that point, what you do is there's a certain like testing frequency depending on the class every 6 months or so. It kind of depends. So what I see people do is they'll stick a piece of paper on the bottle and they'll say, test it on the state or 100, just be careful with it, but it's something that you can use. If it's something that you're going to be like evaporating or heating up in a reaction with a catalyst, I would say use a fresh bottle for that. But a lot of that are the higher hazard ones have that inhibitor in them. Diethyl ether has it, tetrahydrofuran has it too. The alcohols don't have it, but they in general don't form isoamyl alcohol that I'll see peroxide concentrations in.
Yeah, we used to use a lot of anhydrous ethyl ether.
Yes.
And we would always date it, and after 6 months, all we did was add water to it.
Yep.
Because I was told that would get rid of the peroxide, to keep it safe until it could be picked up. Is that an old lifestyle or is that?
A reducing agent in it. Sometimes what we'll do is we'll add I can't remember what the salt solution is, but what we did to the rest of this drum right here is we added something that would neutralize the peroxides, and then we pumped manually. It had to be pumped in, so we neutralized it within the drum. And I can't remember what salt we used to neutralize it with. But dilution helps though, because part of the reason because they crash out of solution, right? So dilution does help, and if it's soluble in water, it might help.
I would add like a few mils.
Check into that.
A few mils of water would cause the peroxide to degrade, is what I was told.
Okay.
I don't remember reading that.
Yeah.
Just wondering if that was true or not.
I'll have to look into that. It's possible that or solubilize them. So that was potentially explosive chemicals. So that's kind of chemical storage and management, chemical handling. We'll go through this. The first step is just a hazard assessment. We had in 2020 where a person's reaction flask detonated on them. And it's a nice example of how safety glasses and goggles can save your eyesight. So with hazard, working with what chemicals are you working with? What are the experiment conditions? So looking at, what temperature is it at? What pressure is it at? Things like that. Looking at the scale and then understanding how to scale up if necessary. We've had one of the incidents that happened because that person scaled up. Actually, no, it was this one. He did this on large scale. So he did this reaction on large scale without testing it on small scale first. And he was using a new substrate and it did. So that's just an example of if you're going to scale a reaction up, make sure you test it on small scale first and then test and scale it up in increments. What environment are you performing the experiment? Them in the field, or you might have to use them in a room that's not designated as a a lab room. So if that's the case, what are you working with, and is it still safe in a room that's not, your normal room that has hazards that you might have? And so in some cases, there are mechanical hazards, right? You have something that's pulverizing or grinding, or there are electrical hazards, things like that, that might be kind of beyond the scope of normal. It kind of depends on what your normal lab, get that hazard assessment, and Evan can help you with that too. We usually go through the hierarchy of controls to kind of make sure that what we're doing is safe. So can you eliminate the chemical that's the most hazardous or the most toxic? Can you eliminate it, or can you substitute it for something that's less toxic? Do you have engineering controls that can help you? So this is your ventilation, things like that, that are built into your deviate inhalants. Do you have kind of like your administrative section, right? And the warning is like, if you have, say like CO monitors, in some cases, people that have a low oxygen detector. So is there a warning piece within your facility that could alert you? The administrative controls is like your SOPs, making sure people are trained. And then the last line of defense is your PPE. So think of that as you reduce the impact of your injuries because the hazard has already gotten to you, right? It's already gotten to through all those gates. And so remember that when you're developing your SOPs, and then if there's something new or something that always help with that hazard assessment piece. And then what comes from that is your SOP. So I don't know if you're familiar with these, but we do have hazard class SOP. The one that I don't have is the reactives hazard class template, but we have that one too. That's really storage and transport of like pyrophoric chemicals, which I didn't think was applicable here, but we have, flammables, oxidizers, corrosives, gets you like 90% of the way there for like good general working practices. And then you can insert your own lab specific procedures into them and use those as training documents for your staff. And so oftentimes when there was a procedure that I would go through the SOP, do it in front of them, and then they would sign off, that we've been trained to do the procedure, right? And that's a good documentation that you can have. And that's something that if there's an incident required for high hazard operations, that's kind of up to this audience as to what's a high hazard, right? If you're a really simple lab, working with a highly toxic material might be like the most hazardous. Staff understand it. If chemical synthesis is really common to your lab, maybe it's a specific one that you consider the most hazardous, that you might want to have a written document that says, this is how, and you probably already have them, but most of them tend to focus on, making sure that the procedure or that the things are pure, right? That your procedure goes well and you get a good yield, just adding safety into that combined. General safe working practices, you can read through these, but making sure you review your SOPs, making sure that you work during normal hours or that you have a buddy. And the two incidents that I mentioned kind of in the evening, but they had a lab mate that helped them when they got hurt, right? And that was even more so during the pandemic, that people were kind of left alone. Test on the reactions on small scale, work in a fume hood if you have it, if you're working with volatile compounds or where there's an inhalation hazard. Use a blast scale for gram scale because the general fume hood sashes aren't rated for above a certain thing. That might not be applicable here. And then make sure that you wear kind of your base PPE during the routine chemical work because that'll help minimize any injuries too. Emergencies, thinking about what to do in the case of an emergency when there's a medical emergency. So if you get caught or someone's bleeding or if someone's knocked out, always call 911. Because it's up to them to assess whether or not you need additional medical care. If you do have to call 911, make sure if you're escorting someone who's hurt, that you stay on the scene to tell their first responders what happened and what you were using. In all of our scenarios that we've done with the fire department, that was the single most helpful thing to get involved. Here's a safety data sheet, versus like getting handed a 300-page inventory, right? And saying like, oh, figure it out. Another thing is notify UHS and notify the department head. We've had situations where the department head doesn't know until they read it in the newspaper, and we don't want that to happen either. And then we have an emergency procedures fact sheet and a chemical spill. But lastly, I want to get to the disposal, and then I have a slew of questions at the end of this. So in general for chemical disposal, so we've gone through chemical management use, and now we're at disposal. The University of Minnesota, this is in pounds of waste, and mostly it comes from the Twin Cities campus. You can see all of the campuses listed and some of the research and outreach centers too. We do collect waste from Fairview. So Fairview Health Chemical Safety Day program where we go around, we collect waste from small institutions around the university because they just might not have the facility to do it like we do. From there, the chemical waste requirements, we kind of go from like the beginning. So choose a compatible container in a secondary containment tray. That's one of the common violations that we see. Make sure that it's labeled with the words hazardous waste and that it has the components on it, and that you check those hazard labels on the yellow label. And those are provided by UHS. So if you need more, let Evan know and he can bring some by hazards. And then it's submitted in Chematics, and usually the turnaround time is about 2 days. I will say that right now Chematics is having some issues. So if you're having issues disposing of waste in Chematics, at the end of this, I have Robbie's contact information, and she helps us with all of that. So, and it's a glitch in the system that's happening right now. So it's not common. From there, so you just have a funnel in it and it's kind of left to evaporate, right? So that's one of the violations. The second one, the one in the middle, so even if it's in a fume hood, it's not consistent. It has to be in that secondary containment tray in the fume hood, and that prevents it from kind of spilling, spreading, and evaporating, right? And then the third one is, this is HPLC waste. So you can kind of see it, it's the, if I can, right here. This bottle has the HPLC lines going into it and down here too. So the waste is flowing into it, but it's not capped. So it doesn't have those drilled caps, which are required for it to be considered closed. And then this, the bottom carboy has a flammable sticker on it, but it doesn't say what waste is in it. It just has the flammable sticker on it. So both of those are kind of missing things. For the general, yeah.
Use up all of the reagent that was in a bottle.
Yep.
And you're just letting it evaporate, so it's like not a considerable amount. Does that sound to be
Yep.
secondary?
No, that's okay. You would recycle the bottle and that's fine. Yeah. And then so if you use up all of the reagent in a bottle, you should cross off the label it as empty, and then set it out. And what we would do is we would actually leave the caps off so that FM knew that it didn't have anything in it. For you, you could theoretically store it indefinitely. Is that a good practice? Definitely not. So we recommend 6 months to a year in your lab areas, as long as it's not deteriorating or evaporating, submitted for disposal. So when it's on the sheet and it's like kind of in that disposal process, we have 90 days from when it gets on that sheet to when we ship it off site, right? How do you dispose of an unknown? There's a super easy. So if you have an unknown, fill that form out. DHS used to charge for unknown analysis. Now we don't, unless it's like you submit, over 10 unknowns or something. And then they might make sure that the waste isn't flammable, oxidizing, corrosive, things like that. And then that way that it allows them to ship it out in the stream that they need to. And then how do I dispose of hazardous work? Even with acids and bases, we never, at this point, we've stopped letting people neutralize it and dump it down the drain. If you want to sink dispose of something, you need written permission from the waste program. And it's so much easier now that before it used to take weeks and you'd have to fill out a physical form. Now it's pretty easy. Yeah.
And what about buffers?
Buffers that are non-hazardous is fine. Bleach solutions in general are.
For example, the extraction or
Yep.
something, then you have some sample which is hydrated with that.
Yeah.
How to dispose that? Does it need to go through the program, or we just?
Depends on what the component of the
they
waste
start with the
is.
solution, but you end up with something like a paste. for
Yeah.
example. So
Yeah.
it's
So
a
the
solid material.
Okay, so in that case, I would just email the waste group, or that it's something that can be sewered. Because that's something that we can get fined for too. Like if someone comes in and analyzes a waste stream that gets thrown into the trash, it's not like they monitor what goes down the drain, but if they realize that like a custodial staff, we could have issues with that. So they know like what hazardous materials can go in the trash and what can't, if that makes sense. So either email them or just dispose of it. You can always dispose of something through Chematics.
We start with a buffer, for example, we mix it with SDS or BME.
Sure.
Something like cancer causing or
Yep.
flammable. Then we use it for extraction. You end up mix it with, or you end up with a
Yep.
sample, you analyze it.
Yeah.
How to dispose this, which contains
Yes.
the buffer plus the hazard.
Okay, I got you. Sorry. So that would just go through solid. You could put that through solid waste, right?
Dispose it in the trash.
It depends on the possible percentage of what's hazardous. So that's something that we can talk to the hazardous waste group about, because in general, exceptions, but unless they know the components, they can kind of think about the percentages, they'd be able to say once and for all, yes or no.
So if you have to explain what are you using?
No, I think what we would do is just kind of talk about your general work, and they could probably make a general determination. So it wouldn't be each case. It would be like overall, when you're doing this process, if it involves adding these to sink dispose, there's usually a range that they give you. Yeah, it's a touchy one. And then from there, how should food components be listed on the chemical waste? So in this case, the food components would add to the total weight, but it would be listed as whatever it is. So if it was, say, grains, you could put grains into Chematics, and if it's not already in there, just give it a Z number, and they'll know that there's a person on the other end that will. And then the other question was, when filling out the waste by percentage, if you choose trace, what that means is below 1%. So if it's below 1%, you put it in as trace, because then when it will, for that, it's kind of, unless it's something that's really highly toxic or potentially environmentally hazardous, that percentage, if it's so low, you have a situation where it could be like mercury or something like that, where put it into a different disposal stream, that small percentage might make a difference. But in general, if it's trace, just put trace thing, but at least the waste group will know that it's in there. What's the best way to do solid waste? So for example, paper towels or contaminated labware. There are Z numbers for paper towels, contaminated. So you can list those things because they're part of the total waste. And then you would list trace other things. So if you used it to clean up a spill, for example, so if you had a spill of a solid hazardous, highly toxic material, and that would be something that you would dispose of through them versus putting in the trash. Solvents, you know, if you're cleaning up a small spill of a solvent, probably the solvent's going to evaporate before it would even go into the waste. Have like highly contaminated gloves or paper towels or spill pads, those are the ones that go through waste. And then mercury. So mercury is its own waste stream, and it's a more expensive waste. Looking at a mercury thermometer, you can either, I would argue you should, if it fits a mercury thermometer and anemometer break, you should call UHS in general, because we can come out with like a mercury detecting machine used for used with chemicals for many, many years. Will oftentimes, like during construction projects, they'll pull up a floor piece and they'll find a bunch of mercury in there. So if there's a mercury spill, if you're disposing a mercury thermometer, say that you replaced it with an alcohol thermometer, that can just go in a Ziploc bag and be put out through the hazardous waste program. So they know there's a whole different stream for mercury. Yeah, I was gonna say last is just make sure that it's by itself. So like if you have mercury thermometers, don't add it to a bunch of other things, because that just increases the poundage and it's quite expensive. I think that's my last slide. So these are some of your normal contacts. So your research safety partner is Evan, your biosafety partner is Nancy Rolstead, and then Robbie Eaker is, and I will end with this.
So for hazardous waste, as both biological and chemical.
Yes.
Is that only going to be biological stream, or is there anything that you want?
Yes. So, and chemical, a lot of times those will go through like the yellow bag waste stream. So for that situation, so there's red bags can be autoclaved, and then you have your autoclave bags, of course. And then the yellow contaminated with chemicals as well. So things that can't be autoclaved, those go out for incineration off-site. There are certain things that cannot go out in yellow bag waste. And that's like if you were using strychnine or something like that, we might have to have a conversation, and that may have to go out through chemical waste. But biological waste could go out through chemical waste. It's not against the rules or anything. You just need to identify incineration anyway. It would just go through a different stream. Does that make sense? Okay. Yeah.
So our lab has a lot of HPLC.
Yes.
Ethanol, methanol, methanol. So when it's empty, you want to put and then dispose them
Yes.
in the regular bottle.
Yeah. Yep. So the question was, their lab uses a lot of solvents bottles, and so the question was, is mostly empty, air them out in the fume hood, and then recycle them is usually what happens. So what I would do in the chemistry department is you cross out the label, write empty on it, and then I would put it next to the recycle. You can put those bottles in. Otherwise, you can reuse those bottles for waste. You just need to make sure that it's compatible with the waste stream you want to put in it. And then the same, so for like solid bottles, so like say you had a salt bottle, right? So you had as long as it's less than 3% of the original components of the bottle, then that can be thrown in the trash. So that's something that has so little contamination in it that it can go into the trash. It doesn't have to be disposed of through the waste program. Residue, I would say maybe dispose of it through the waste program, but if it's less than 3% of the original volume, it technically goes in the trash. Yeah.
Kind of a trivial question, should go in the trash or the plastic?
If it's, yes, so glass waste, yes. Yep. If it's I was thinking of plastic bottles. So you can do either one. The glass waste technically goes in the trash anyway. It's just a way of, and you can email any one of these people with questions. And I'll give you the slides, and my slides have some of the notes of what I talked about too.
Yeah, I think we should have this on.
I can take off maybe.
Yeah, thank you so much.
All right.
Yeah, I think
Yeah,
we're time
we are.
now, Jodi, but yeah.